So, hello and welcome everyone. Welcome back. So, I hope I'm audible to all of you. We are live again on this particular platform of Tutee Learning JEE. So, I hope you are doing well, right? So, we have already covered another basic lecture on the forms of equations of circles, right? So, we have taken so far two lectures on circle equations and where we have understood how to solve the questions on the equation of circle with the respect to the given properties, right? So in today's class, also we are going to do the same thing. We are also going to discuss about the different equation of the circle forms, and along with that, we are also going to move towards understanding about the position of a point with respect to a circle. So, and then we're going to move into the position of a line with respect to a circle, right? So that will be the main agenda of today's discussion. Okay, I hope this particular lecture is going to help you a lot in understanding the basic concepts. So without further ado, let's get started. And before I start, again, another very quick announcement, as I already mentioned in the last video, is that from 26th of November, okay, on this particular platform, we are going to start with our live revision one-shot sessions. Okay, so those particular lectures are definitely going to help you a lot in understanding and preparing for your upcoming JEE Mains first attempt. Okay, so please stay tuned for this particular contents because those will be very useful and important, especially if you're looking for your quick revision. Okay, and this particular platform is going to help you a lot in doing that, right? So if you're new to this particular channel, please subscribe and also hit the bell icon so that you always get a direct notification the time we are live on this platform, right? So with that, without wasting further of time, let's get started for discussion on the different forms of equation of circle, and we will try to wrap up now. So, so let me quickly discuss about the other different forms of different forms of the equation of a circle. The equation of a circle. Okay, so let us quickly understand about the different form of the equation of a circle, right? So what are the other miscellaneous forms of equation of circle that we can have? I'm going to discuss it right now. So let us discuss a first form. Let us say we have a circle which passes through the origin and has the intercept of alpha and beta on the x and the y axis respectively. So let us say this is x and y. The circle passes through the origin. The circle passes through the origin over here and has an intercept of alpha comma 0, that is basically alpha is the x-intercept, so therefore the coordinate where the point intersects the x-axis is going to be alpha comma 0, and the point where the circle intersect at the y-axis is going to be 0 comma beta, because I mentioned that alpha and beta are the x and the y-intercept, right? So this is how the question will look like. So we'll have somewhere the center over here, and now we have to formulate the equation of the circle, right? So if I draw this AB line, what you can observe is that this origin, which is another point on the circle, is subtending an angle of pi by 2 at the line AB. That basically means that the center is also lying on the line AB. That means that AB line is my diameter. Okay, so therefore what I will obtain is that I will get my AB line to be a diameter, right? So therefore I have the opposite or diametrically opposite points of the circle, and from here I can easily formulate the equation of the circle, right? So if I do that, I'm going to get the relation something like x minus 0 into x minus alpha plus y minus 0 into y minus beta, and that should be equal to 0, right? So if I expand this, I'm going to get the result as x squared plus y squared minus alpha x minus beta y is equals to 0. So this is going to be the required equation of the circle. Okay, so the circle equation is going to look like this. I hope this is clear. Is this part clear? Okay, so similarly, let us now quickly look into the other form of the circle, that what happens when your circle touches the x-axis. Okay, so if your circle is touches the x-axis, that means the x-axis is the tangent to the circle. right? So if your x-axis is a tangent to the circle, let me draw it properly. So this is how it will look like. So if your x-axis is a tangent to the circle, then let us consider the center as alpha comma beta. What I can see is that the radius will be, this radius will be equals to beta. The radius of the circle will be equal to beta because it is intersecting the x-axis or touching the x-axis. It is not intersecting, it will be better called as touching the x-axis, right? So circle which is touching the x-axis at point M will have the radius as beta, right? That is the y coordinate of the center. So therefore the equation of circle will become x minus alpha square plus y minus beta square will be equals to beta square. So that will be the equation of the circle touching the x-axis. And in a similar manner, if I ask you this question that what will happen for the equation of the circle which is touching the y-axis, right? So in a similar manner, you can also think of this particular case when the circle is touching the y-axis such that the center is alpha comma beta, then in this case the radius will be equal to alpha, right? So in this case the circle equation is x minus alpha square plus y minus beta whole square will be equal to alpha square. So this is the case when your circle is touching the y-axis. Is this part clear? So touching the y-axis is this is the equation of the circle, right? This is the equation of the circle touching the y-axis, and this is the equation of circle touching x-axis. I hope these two results are clear. I hope these two results are clear. In a similar manner, if I talk about what will happen if the circle is touching both the x and the y-axis, right? So for the circle touching both the x and the y-axis, in this case, what I will obtain is that, so the circle is touching both the x and the y-axis, something like this, right? So in this case, I will have the center as, let us say, alpha comma alpha, because the radius in this particular perpendicular distance center from the x and the y-axis should be equal, right? So in this case, this alpha and beta should be equal, and that's how the center will be alpha comma alpha, right? So in this case, if I consider the center as alpha comma alpha, then the circle equation will be x minus alpha whole square plus y minus alpha whole square is equal to alpha square. Okay, so this is how the equation of the circle will look like. All right, is this part clear? Okay, so these are the all important modification that you can have or expect to see in your problems, right? So maybe we can solve some more problems to understand what all different types of problems you might encounter, right? So let us take up some few problems to understand this particular scenario, right? So let me take a very simple problem to start with, and then we move on to another interesting problem, and with that we finish off with discussion on the different equation of the circles. Okay, so different forms of equation of circle will be ended with that, right? So please try to solve this problem. Please try to solve this problem. Everyone, please try to solve this problem. Okay, very interesting problem. So as the question mentioned that we have to find out the equation of the circle which touches both the axis and the straight line in the first quadrant lies below it, right? So again, this question is saying that the circle touches both the axes. That means your center should be a symmetrical point like alpha comma alpha, right? So that means the center will lie on the line x equals to y. So if I try to draw this scenario, so let us say this x and y axis, the circle is touching both the x and the y axis. So it is difficult to draw like this. Anyways, and the line and it also touching the line, the straight line above it, right? So this straight line is given as with the equation that is 4x plus 3y is equals to 6, right? So this particular line lies above it, right? And the center of this particular circle is definitely going to lie on the line x equals to y, right? Because if I consider the center as alpha comma alpha, because it is touching both the x and the y axis, right? So this is how the scenario would look like, right? So we have to formulate the find out the equation of the circle which touches both the axis and the straight line in the first quadrant. Okay, it's mentioned, it is also mentioned that the circle touches this particular straight line in the first quadrant and it lies below it. Okay, and it lies below it. So with this particular formulation, you have to solve for the question, right? So how are you going to solve for the problem? Let us try to understand. Now, since this particular line, this 4x plus 3y is equal to 6 is another tangent to the circle, therefore, if I draw a perpendicular from the center to the tangent, so if I look at the condition of the tangency, so if I have a circle like this and it is a tangent point, so if I drop a perpendicular from the tangent to the tangent, let us call this point as t, then this particular perpendicular distance it should be equal to r, right? So that is my condition of tangency. So if I draw a perpendicular on this particular line and I find the perpendicular distance, let us say the distance is equals to, so alpha comma alpha, this will become equals to um, 7 alpha minus 6 whole divided by 16 plus 9 square root of that, and that is going to be square root of 25, which is going to come out as 5, right? And that will be equal to alpha. So if I solve for this equation, over here, I will obtain the values of alpha as 3 comma 1 upon 2, as 3 comma 1 upon 2. So these are my two values of the alpha I will get, right? But please make sure that your circle is lying below the straight line and is intersecting only in the first quadrant, right? So how am I going to decide that? Now since, so this is 0 comma 0, so if I take alpha as half, the center will be half comma half, right? So if I take this particular form, then the equation of circle will become x minus half whole square plus y minus half whole square is going to be 1 upon 4, right? That is how the equation of circle will look like. So if I expand it, 4x square plus 4y square minus 4x minus 4y plus of 1 is equals to 0, right? So that is the equation of the circle. Okay, now, and why did I choose the value of alpha as half? How will you understand this? To know about this, that why I am choosing this alpha value as half, you have to please make sure that what you can understand is that if you try to take this line, now you have to make sure that this alpha and the 0 comma 0, this origin lies on the same side of this straight line, right? If your center lies over here, so maybe if your center is lying somewhere over here, that is, let us say 3 comma 3, if your center lies somewhere over here, so 3 comma 3 and 0 comma 0, that is not possible because your circle, your straight line has to be lying below the, so circle should lie below the straight line, right? So this alpha, so if you take 3 comma 3 and 0 comma 0, you will see that these are lying on the opposite side, whereas opposite sides of this particular straight line, let us call it L. Whereas if you take 1 by 2 comma 1 by 2 and 0 comma 0, then these 2 points are lying on the same side of the straight line. That basically means you have to take the value of alpha as half. Okay, so this is how you would solve the problem over here. I hope this question is clear. Is this question clear to all of you? Please do let me know if you have any questions, any queries. Is this question clear? Is this question clear? Okay, so do let me know in the live chat, is this part clear or not, or so that we can keep on discussing about it. Okay, so maybe with this particular understanding, I think you must have understood this question clearly. So then what I can do is that I can give you another few problems to practice, right? So maybe take this problem. So take this problem as a homework problem and try to solve this. Okay, so please try to solve this problem as another homework problem, right? So please write it down, okay, or maybe take a screenshot of this and try to solve it, this particular problem, and do let me know whatever answer you're getting. Okay, so this is the question that is given to you. So it's a question again on the equation of the circle passing through the point minus 4 comma 3 and touching the two lines x plus y equal to 2 and x minus y equal to 2, right? So try to solve this problem. It's a quite an interesting problem, and if you try to solve it, you will be able to get to the final result, right? So maybe the a standard result has to be applied over here. So again, you know that when the when any given line is a tangent to the circle, so the distance from the center of the circle will be equal to the radius, or the perpendicular distance from the center to that particular line is going to be equal to the radius of the circle, right? So with that particular concept, you can easily solve this problem. Okay. So I hope you have taken a screenshot of this problem and try to solve it, and do let me know whatever answer you're getting in the comment section. Okay. So with this, we are now ready to discuss about the properties, the general properties of the circle with respect to a point. Okay. So now I'm going to start with discussion on the of a point, position of a point with position of a point with respect to a circle. Okay, so now let us try to understand how to find out the position of a point with respect to a circle, right? Let us try to discuss about this now. So if I have any point, that is, let us first of all assume the equation of circle. So the equation of circle is going to look like x square plus y square plus 2gx plus 2fy plus c is equal to 0, right? Now I will soon see that I will use this particular equation and call it by some operator which is called as s. So I will be naming this as like shorthand operator, that is s. So I will be writing that s equals to 0. That basically means the circle equation, right? So now we know that the center of the circle is basically, from this general equation, we know the center of the circle is basically minus g comma minus f, right? And the radius can also be known to us, that is basically square root of g square plus f square minus of c. So this is the radius of this particular circle, right? Now how am I going to decide whether the, well, let us say any point which is given as, let us say alpha comma beta, okay, or maybe let us say x1 y1, right? So I'm going to use a standard nomenclature x1 y1. Okay, so let us say x1 y1 is a point P, right? Now how am I going to decide that by how, or whether this point P is lying inside the circle, on the circle, or outside the circle? So in order to decide that, so first of all, if I have to define this point P on the circle, then this my CP distance should be equals to the radius of the circle, right? And if the point lies interior to the circle, then CP should be less than R. So this is the condition for the point to lie interior. And if my CP is greater than this radius R, then it is basically an exterior point, right? It is an exterior point, right? So depending on this particular three condition, I'm going to decide and judge whether my point is lying outside or inside. So if I solve for like CP less than R, what the condition I will get, that is basically S1 is equal to 0. Now what is S1? So as I mentioned that I already wrote the shorthand operator of the circle equation as S equal to 0. So in this circle equation, if you put x1 y1, in this circle equation, if you put this point x1 y1 and calculate the value, so, and without just thinking of the right hand side, so if you calculate the value by putting x1 y1, that is called as s1. Okay, so in the equation of circle S, so if you put the value of x1 y1 in this equation of circle S, if you put the value of x1 y1, so this will give you your required point or required expression, that is s1, right, or the required value of the expression s1. So when your s1 is less than 0, that basically means that the point is interior of the circle. And similarly, when your s1 is greater than 0, that basically means that the point is exterior. And similarly, when s1 is equals to 0, that basically means it is lying on the circle. Okay, so these are the three important conditions that you need to remember for this particular case, right? So if you try to do this algebra, you will be able to get to this s1 less than 0, greater than 0, all those stuffs, right? So maybe you can try it out on your own and try to get to this particular formulation, right? I hope this is clear to all of you. Is this part clear? Is this part clear to all of you? Do let me know if this part is clear or not. Okay, so maybe we can move forward with discussion on the how to find out the minimum and the maximum distance of any point with respect to a circle, right? So let us discuss about that as well. Okay. All right. So let us quickly discuss about how to find out the minimum and the maximum distance of a point with respect to a circle, right? So now by far we have understood that whether the point will lie interior to the circle, on the circle, or exterior to the circle, right? So now we will discuss about how will I going to find out that if I have the circle over here, how will I find out the distance or the maximum distance of any point with respect to the circle, right? So if I have any point, let us say P, which is x1 and y1, now any distance of this point P from the circle is going to be maximum, or the minimum is definitely going to lie along the common normal, right? So the common normal is obviously going to pass to the center of the circle. So in order to find out the minimum distance or the maximum distance, we have to draw a line passing to the center and that particular point. And in order to, so this particular point, let us call it as A, and this point is called as B. So this PA will give me the minimum distance. This PA will give me the minimum distance of P from the circle. Okay, the minimum distance of the point P from the circle is given by PA, and PB will give me the maximum distance, of P from the circle. Okay, so the minimum and the maximum distance will always occur along the common normal. Now, how am I going to find out this particular distance? Is very simple. So in order to find out PA, we have to find out CP, because this is very easy, minus the radius, right? And similarly, in order to find out the maximum distance, that is PB, that is basically radius plus CP. Okay, so this is how we can easily find out the maximum and the minimum distance of a point from a circle, right? Now this concept is very important concept, right? So maybe in questions of complex numbers, also in questions of calculus, we will see a lot of usage of this particular concept that will come up in our following discussion. Okay, so please take a note of this particular discussion and keep this particular thing in mind, so that when we solve questions, you can directly apply this to the given problem and we can quickly get to the answer. All right, I hope this is clear to all of you. I hope this discussion is clear. If you have any question, do let me know. Any questions, any queries, please let me know in the live chat. Okay, please try to understand this particular part very carefully, because it is going to be very important. Okay, is this part clear? Is this part clear? All right, so let's now move on to understand the concept of a line and a circle, right? So right now we were discussing about the point and a circle, and now let us quickly go on and understand the important concept regarding the intersection of a line and a circle, right? So let us understand the intersection of line and a circle. Okay, so let us try to understand the concept of intersection of line and a circle. So let us take very simple case to begin with. Let us take the equation of circle with the center as origin, with the origin as a center and the radius as a, and the, let us say, the line equation is given as mx plus c. Okay, so what I'm going to discuss is that this particular circle is with the center as 0, 0, and any line like this, which is given as y is equal to mx plus c, is my given line. So whether it is intersecting the circle at 2 points, or whether it is just touching in the circle, or whether it is lying exactly outside or completely outside of the circle, how we are to decide is again the simple concept is that, let us consider this line and the center as c. So what I'm going to do is that I'm going to find the perpendicular distance, right? So let us call this point as P, where the line midpoint we will have, because whenever I draw a perpendicular on the center to a given line, it is definitely going to bisect that given line, right? This is one of the important property which you have all learnt it in your junior classes, right? So depending upon whether my CP is less than R, or CP is equals to R, or CP is greater than R, I can tell out. So if this CP, this distance, is less than R, then this is the case of the chord of the circle. If your CP is equals to R, then this is the case of the tangent to the circle. And if your CP is greater than R, then it is basically a line lying outside, okay, outside the circle. All right, so this is the important concept that we need to solve for, right? Now, how am I going to solve for, and whether I'm going to check it at how many points? Also, what I can do is that I can substitute this value of y in this particular equation, and I will get a quadratic, right? So if I do that, so I will get a quadratic in x, right? So, and then solving for the quadratic in x, so it is going to look something like, so m square plus 1 times of x square plus 2 times of m into c into x plus c square minus a square, right? So this is how the quadratic equation would look like. So this is another general quadratic equation in x. So if this quadratic equation has two roots, if this quadratic equation has got two roots, that means that the line is a chord. That means you will have 2 points where the line is intersecting the circle, right? So if it is having the discriminant greater than 0, then it is a chord. If the discriminant is equals to 0, then it is a tangent. And if your discriminant is less than 0, then it is lying outside. Then the line is lying outside. So let us try to solve for these three, and we'll distinguish the three cases over here. So if you solve for the case of chord, what you will get is that means your d is equals to 0. So this particular case will come out to be a greater than mod of c divided by root of m square plus 1. So this is a condition for the chord for a given circle, a line being a chord. For tangent c, the condition is a is equals to mod of c divided by root of m square plus 1. This is the condition for tangent c. Okay, this is also the condition for tangent c. And for the line to lie outside the given circle, then the condition is that your this a value should be less than mod of c divided by m square plus 1. So this is the condition for lying outside the circle. So this is the most important consideration that you need to keep in mind, that the tangency condition is that for a given circle with the origin as a center and radius as a, the tangency condition is like this as follows. Now what happens if my center is shifted to alpha comma beta or any arbitrary value, then how this condition of the tangency is going to modify, we're going to discuss in the upcoming lecture. Okay, I hope this is clear to all of you right now. Is this part clear to all of you? Is this portion clear? Right, so these are the three important consideration that we need to keep in mind while we solve for the condition of tangents, right, or the condition for given line to be a chord, right? So please keep this in mind as we move on to solve some questions. Okay, and then we can discuss about another important discussion about the segment of a secant, chord and tangents, right? So all those things will come up and follow simultaneously from this following lectures. Okay, so with this I would like to conclude the session over here, and in the next class when we're going to meet, we're going to solve some varieties of questions involving the point and a circle, line in a circle, and all those general stuffs. And with that we're going to move into discussion of the different forms. Now we're going to move towards understanding the tangents in general, right? So now we are going to understand how do we write the equation of tangent to a given circle at a given point, and all those different formulation or all those different cases to write the equation of the tangent. So we are going to look into the tangent concept or writing the equation of a tangent for a given circle in the upcoming lecture. So till then, I wish this particular lecture was helpful to all of you, and I hope it helped you to understand the basic concepts. If you still have any question, do let me know in the live chat, or maybe you can leave that up in the comment section. Okay, and if you are really curious to study online one-on-one, and maybe you have got a lot of backlogs to cover before your JEE Mains examination, you can always contact us on the number that is given on the screen, or maybe in the live chat you can check out the number, or maybe you can find a particular contact number in the description box. So please contact on this number to get access to the live batches, or maybe you can ask your queries or your doubts from that particular number by contacting us on this number, right? So with this I would like to conclude, and I thank you for your lovely attention, and I hope to see you soon in the live class next time. So please subscribe and also hit the bell icon, and also share these videos with your friends, your relatives, or maybe your juniors. Okay, this is going to help us a lot in reaching out to the masses, right? So thank you, and I wish you all the best.